Hello, nerds! Today on Neutrino Tech, we're gonna be melting hearts. Aww. We're gonna be melting faces. But most importantly, we're gonna be melting steel. And a few other household objects, all with a little touch of chemistry. So stick around. For those of you that watch my channel, you might have noticed I really enjoy making things that I can use to set on fire. Surprise, surprise, this is another one of those videos. Today, we're playing with, carefully experimenting with thermite. If you've never heard of thermite, essentially it's a pyrotechnic concoction that can be made from various combinations of metal powder and metal oxide, and it burns ridiculously hot. Like, we're talking melting through steel kind of hot. This stuff has been used for anything from welding railroad tracks together to anti-tank weaponry. And the best part? It's so easy to make.
Don't try it!
The most common type of thermite is made from aluminum powder and red iron oxide, better known as rust. But theoretically, it can be made using basically any reactive metal and metal oxide as long as the reaction is thermodynamically favorable. When a thermite reaction is initiated, the materials undergo a violent exothermic oxidation reduction reaction in which the oxygen atoms from the metal oxide are transferred to the reactive metal. In the case of traditional thermite, when a sufficient amount of heat is applied, the oxygen atoms will leave the iron oxide and form a stronger, more stable bond with the aluminum, giving off an immense amount of heat in the process. This is why, when designing new thermite, it's important for the fuel metal, in our case aluminum, to be more reactive than the metal oxide. In the end, you'll be left with aluminum oxide slag and basically pure iron. To make thermite, the first thing we need to do is weigh out our ingredients in the proper stoichiometric ratios. If we take another look at the equation, you can see for every molecule of iron oxide, we're going to need 2 molecules of aluminum. Iron oxide has a molecular weight of 159.69 grams per mole. Aluminum is 26.98 grams per mole times 2 makes 53.96. This means for every 1 gram of aluminum, we're going to need about 3 grams of iron oxide. Once everything's weighed out, we just put them both into a container and mix them up real good like. All right, so now we've got a good bit of thermite and we're basically ready to light it up. A quick note about lighting thermite. While it's technically possible to ignite it with something like a propane torch, it's not generally the best approach, as it can take some time to begin the reaction, and preheating thermite is a recipe for disaster since it can cause it to burn nearly instantaneously without giving you any time to reach a safe distance. Also, a standard black powder fuse doesn't get hot enough to start the reaction. Instead, the best way is to use magnesium ribbon, or even a sparkler firework, since these burn at a high enough temperature to ignite the powder. So what are we gonna melt today? First up on the chopping block is a standard padlock. I think this should give a pretty good indication of how hot our thermite actually gets and test a few theories that we've seen in TV shows and movies. Next up is gonna be a good old-fashioned lockbox. Had this thing sitting around for a while and I think it's about time that it retired, so let's see if we can burn right through it. And then last, but definitely not least, I want to burn through a laptop. This is an old laptop that is out of commission and I'm a pack rat, so I didn't throw it away, but it's almost 10 years old. I did take out the lithium-ion battery because that just sounds like a recipe for disaster, but thought it'd be really cool to see what thermite could do to a laptop. So let's check that out. Initially, I tried just dumping the thermite onto the master lock and lockbox and just lighting it. But it didn't take long to realize this wasn't going to be enough. So to really cause some damage, we have to find a way to slow down the reaction and direct the heat to where we want it to go. I had a few steel pipe flanges sitting around that I thought would be perfect for this, so I set it directly onto the lockbox, filled it with thermite, and packed it down as much as possible by hand. It's a little fluffy, so this board wasn't the best tool, but I made do. We will make it through this box. I'm working with what I got here. The box is red hot, and that definitely slowed down the thermite, practically welded to the box. We actually made it through the box. Got metal shrapnel everywhere, but it is still locked. We made it through. The lock still works though. If anything, this video is probably a pretty good advertisement for Brink security boxes. Good job, guys. Knowing what I know now about slowing down the reaction and containing it, I want to try to get through this lock one more time.
So troubled, you look so blue. Won't get through to me. Should have told me the truth. And everything's meant to be the same. I'm sorry I learned from my mistakes. It's getting cold on the outside.
Kind of melted through the brick, through the cinder block. Oh, and I officially got through the lock. I'm in. Nice little molten slag on the bottom there. And, oh, there's still liquid metal in here. What is that? Is that aluminum maybe? I don't know. There's some sort of molten metal here. Oh, that's really cool. Whoa. Oh, you got your spring. And the pins from the lock. Those are still intact. I think that's aluminum. I'm not sure what it came from though. It wouldn't have been the thermite. It must have been something inside the lock. Cool. That was fun. Let's see what thermite does to a laptop. We made it partially through. The screen is all bubbled. I doubt it. One of the keys is melted to the screen.
Cold on the outside, but this is where I choose. And bitter things that it tastes nice as I change my point of view. But look on the bright side. You look on the bright side. You look on the bright side. At least it don't hurt.
So that was fun, and I feel like I learned some pretty important information today. Like even the cheap old lock boxes have pretty good insulation that protects against even the hottest of fires. Also, breaking into a bank vault or any locked facility wouldn't be nearly as easy as they portray in the movies. I guess that puts an end to my plans for the ultimate heist. But I did get to melt through a laptop, so at least I have that. So, if you enjoyed watching me light things on fire, click that like and subscribe button. And if you learned something new or have something you want to see melted with thermite, let me know in the comments. But until then, thanks for watching.